Hello guys, welcome back. So here we have another question on communication systems from GATE EC 2021. A speech signal band limited to 4 kHz is sampled at 1.25 times the Nyquist rate. So speech signal bandwidth is 4 kHz and then it is sampled at 1.5 times the Nyquist rate. The speech samples assumed to be statistically independent and uniformly distributed in the range -5 to +5 are subsequently quantized in an 8-bit uniform quantizer. So your whatever is uniformly distributed, right? So your probability density is of the input signal is like this, right? And then what we have, and it is passed through an 8-bit uniform quantizer. 8-bit quantizer. Okay. And then transmitted over a voice grade AWGN telephone channel. So then we are transmitting it through a AWGN channel. So if the ratio of transmitted signal power to the channel noise power is 26 dB. So the signal to noise is 26 dB. So in dB means what is the thing? It is 10 log of S by N. So this is log to the base 10. Since it is in power, we have to use 10 here. Okay. So this is 26 dB. And if this is 26 dB, they are asking the minimum channel bandwidth required to ensure reliable transmission of the signal with arbitrarily small probability of transmission error. So they're asking what should be the bandwidth of the channel B. So if this is bandwidth B, what should be B equal to such that your probability of error is arbitrarily small. So for this to be arbitrarily small, whatever the bit rate we are sending, right, which is given by RB, so this should be less than or equal to your channel capacity. And for an AWGN channel, your channel capacity is given by C is equal to your bandwidth into log 10 of 1 plus S by N, which is your signal to noise ratio. So what this means is, for a noisy channel with additive wide Gaussian noise, if you increase the bandwidth for a given signal to noise ratio, you can increase your maximum rate of transmission. At the same time, for a given bandwidth channel, if you improve your signal to noise ratio also, you can increase the maximum rate at which you're transmitting. So that is what it means. So the derivation of this I'm not giving it here because it is a very long derivation. So for this you just take this to be the equation. So now from here it is straightforward. We already have our S by N ratio, but it is in dB form. We have to convert it into the power by power form, and we need to find the bandwidth B, which is nothing but which we have to minimize. So we have to minimize our B. So to minimize B, what means we have to transmit at a rate of RB, which is also a minimum value. So implies that we have to minimize RB. And your C itself should be equal to RB, right? So these are the conditions. So first let us do the easy thing. S by N. This is nothing but 10 power 2.6, right? 26 by 10 is 2.6. When you take exponential of 10 on both sides, you will have 10 power, S by N is equal to 10 power 2.6. So this is one. So next, we need to find RB. So for that, we need to find the sampling rate into how many bits each time each sample has. Okay. So what is the sampling rate? It's given that F, whatever the speech signal is, 4 kilohertz. So what should be our Nyquist rate? Nyquist rate will be 8 kilohertz. And our sampling rate is 1.5 times 8 kilohertz, which is equal to 12 kilohertz. Sorry, this is, I think, this is 1.25 times, right? This is 1.25. So this will be, so this should be 10 kilohertz, right? So for every 10 kilohertz or 1 by 10 kilohertz, we have one symbol. And for one symbol, how many bit it has? It is passed through a 8-bit quantizer, right? So it has 8 bits. So what is the rate? So rate of the signal at which you need to transmit is 10 kilohertz into 8. So it is 10 kilo, here it is samples per second, right? Into 8 bit per sample. So the sample cancels. So you will get, so this is 10, right? So you will get 80 kilo bits per second. This is your bit rate. So for minimum bandwidth of the channel, we want our C to be equal to RB to minimize B. So your C is now equal to 80 kilo bits per second. So then what is your C? C is nothing but bandwidth into log 10 of 1 plus S by N. So this is equal to 80 into 10 power 3. So B log 10 of 1 plus S by N is 10 power 2.6. 8 into 10 power 3. So this we can use the calculator. Again, here we are considering with dealing with bits. So this should be log 2. So here also it is log 2. And here your units is bits per second. Okay. So this should be log 2. So now if we take, so this one comes to be 0.1157. This is 80 into 10 power 3. So B is equal to, this again is 1 by this. So 1 by this. So your B is 80 into 10 power 3 into 0.1157. So your B is equal to 9.258 kilohertz. So this is your bandwidth required, minimum bandwidth of the channel required, so that your probability of transmission error is arbitrarily small. So here they have asked in kilohertz itself. So you just need to write 9.26. Okay.